down. You didn't bring me anything? Thanks, babe. Can you stay and snack a little bit, babe? Because we went over our free response, okay? All right, this is section 10.1. More rational expressions. Corner seats. Move your chairs, please. Face me. Can you take your highlighters out? Can you please move? Because you're going to be tempted to. Tonight's homework is a joke compared to the worksheet, so you should tear it up. Page 613. You're going to do 1 through 15 odd. Mr. Fuji did a great job of introducing what we're going to do today. And I have a feeling that after today you're going to feel even better. If you're good with your multiplication table, then you're going to be good with finding least common factors, least common denominators. Let's go ahead and just jump into an example here. If I have 1/2 plus x over 6 minus 3 over 2x. Here I would like to have a common denominator. So I need all of these to say the same thing. So I'm going to take a look at what is actually in every single denominator. This right here is just 2 times 1. This is 2 times 3 times 1. And this is 2 times 1 times x. I just need all of these to be the same thing. That's all I need. So whatever one guy doesn't have, just give it to him. But whatever you do to the denominator, you need to do to the numerator. So now you just got to put your thinking caps on. It really is just a game of observation. This guy has a 2. This guy has a 2. This guy has a 2. So you're good. Everybody got a 2 already, so don't even mess with the 2. They all got a 2. This guy has a 1. This guy has a 1. This guy has a 1. Now, whatever the other guy doesn't have, that's your job, is to give it to him. I noticed that my third fraction over here has something that the rest do not have. What does this guy have that the rest does not? X. So since this guy has an x, you need to give this guy an x, and you need to give this guy an x. But whatever you do to the denominator, you have to do to the numerator. You can't just do it to the denominator because now you've changed the value. But if you give him an x over an x, what's 5 divided by 5? 1. What's 20 divided by 20?
1.
What's x divided by x?
X. Oh, 1.
What's 100 divided by 100? 1. What's a million divided by a million?
1.
What's x divided by x?
1.
So you didn't change the value because when you multiply anything by 1, you didn't change the value. What do my rookies do? They will multiply the bottom and forget to do what?
The top.
Okay? You have to make sure you multiply both the numerator and the denominator. Am I done?
No.
No. What does this guy have?
3.
Do these guys have a 3? No, so you need to give it to him. So give this guy a 3, give this guy a 3, but don't forget to put it in the numerator and the denominator. Now you get to drop the denominators because you know the denominators are the same. So all you're really going to focus on, ladies and gentlemen, is the numerator. Highlight that for me, please. Yes, Puppy. Is there a reason I didn't give this guy another x? Doesn't he already have one, Puppy? Now, let's be sure, before we move on, let's make sure all the denominators are the same. Ready? Every single one has a 2. Every single guy has a 1. Every single one has a 3. And every single one has an x. Just always double check before you move on. Does this say 213x? Yes. Does this say 213x? Yes. Does this say 213x? Yes. Does it have to be in the same order? No. Is 2 times 3 the same thing as 3 times 2? is 2 times 3. The same thing as 3 times 2? Yeah, so you're good. Lachey, I need you, babe. You with me? All right, girl. Now I can move on. After all the denominators are the same. Now I just get to multiply. What is 1 times x times 3? 3x. Now there's a plus sign there. What is x times x? X squared. What is negative 3 times 3? Minus 9. Now, is this typically the way we write the polynomials? No, what should I write first? So I have x squared. What sign is that 3x? Positive or negative? So keep it positive. 3x minus 9. All over. Now I'm going to clean it up. What is 2 times 1 times 3 times x? 6x. Thinking caps for 10 seconds. Lachey, keep moving back because I want you to face me. Is this, don't yell it out, is this guy factorable?
Yeah.
Heidi, is this guy factorable? To what and what? What is it factor to? You guys just emphatically, like, for 20 seconds ago, yeah. Kirsten, is this factorable?
Yeah.
What is it factor to?
X minus 3. No. I'm trying to think. I'm trying to do it in my head.
That's why Miss Riad's so annoying with these factoring tests. Oh, they gonna keep coming, bro. Oh yeah, all year long. You're not gonna leave this class saying, I kind of, sort of, I think now I know how to
No, it's
factor.
not factorable.
Let me ask again, is this factorable?
No.
Micaiah, what do you get when you factor it? Because you're saying yes. X plus 3 and x minus 3.
So it becomes X3. You can. 3 and 3 don't add.
Micaiah, what multiplies to negative 9 but adds to 3?
Oh.
All right, so moral of the story, don't get mad at me when you get these surprise factoring tests. They're going to keep coming, bro, like shotguns. Just be ready. Okay? Not to make it your life hard, but for you to realize how important it is to factor. Again, I ask, is this factorable?
No.
Thank you so much. All right. Now, I want to see if there's anything I can simplify. Am I allowed to cut these x's out?
Yes. No.
Why not, Deshaun? All right. What do I notice? These two and these two are attached with a plus and a minus. They are attached to other things. If you have numbers or terms attached by a plus or a minus, you're not allowed to cancel. But what Deshaun is saying is, if 6 cancels all 3, then cool. Then you can reduce it. But you can't just be like, eeny, meeny, miny, moe, you get to go and you get to go. Because this is one whole number, you guys. Isaiah, Ira. So you're not allowed to cancel because it is attached to another part of the number. Let me show you why, because I see people going, yeah, you're right. So this is actually your final answer for example 1. I need you guys to be convinced. Here we go. Why? Victoria, if I asked you like back in math 1 to give me the answer to that, what would you do? 5 minus 3, which is 2, and then 2 plus 2 is 4, and then you get 4 over 6, which reduces to 2/3. Did you notice that this whole thing was one number to get me to 4? Because this is a parenthesis, this is one whole number. Everybody with me? Now, my rookies who like to have canceling parties, They might see this 3 and 6 and be like, oh, reduce that. That becomes a 2 and that becomes a 1. Oh, and look, 2 and 2 reduces to 1. Isn't that what we're trying to do here? Some of you guys are really trying to do that. You're trying to cancel when it's attached to other things. Let me see if I get the same answer. Is 5 minus 1 plus 1 the same as 2/3? What's 5 minus 1 plus 1? What's 5 minus 1? Jesus Christ. Plus 1. Thank you. Is that the same as that?
No.
No. You don't get the same thing. And now I need to be convinced of why. You're not allowed to cancel things when they're attached to other things. This is one whole number in itself. Is everybody with me on that?
Yes.
Cyan, are you with me, Ben? So if it's connected by a plus or a minus, you're not allowed to cancel. Clear? All right, because you don't get the same answer. It's not the same thing. Dylan, are we good? I should have given you guys those free responses after. Now you guys are all butthurt. Why are you mad, bro? Isaiah's mad. Example 2. All right, this denominator is just 2 times 1. This is just x times 1. And this is 5 times x times 1. Let's highlight what they already have. What do they already all have? A 1. You guys, it's going to become redundant. You're going to get to the point where you don't even need the 1. It's like, duh, Miss Riad, I knew the 1 was there. What else do they all have? Nothing else in common, right? So let's give it to them. See what they need and give it to them. Dylan, can you give me one? The first thing I should give? Give me an idea. Okay, let's call this the first term, second term, third term. The first term needs a? Just one? You want to just give them 2? Do you see why?
Yeah.
This guy has 2, this guy has 1, this guy needs 2. So how many does this guy need? 1 more. Elizabeth, what else, babe? Tell me, the first or the third or the second? The first and second need a 5. Josh, what else?
2.
So I'm slowly dying inside because I'm going to say it again. The first, the second, the third. Who needs what, babe? Which terms need a 2?
The second.
Very good. Ashley, what else? Don't try to tick Miss Riad. That's it. Don't they all have the same thing now? All right, Cesar, what's my common denominator? What do they all have? Cesar?
No.
Cesar, you're good, babe. What do they all have in common now?
X.
1x?
No. X squared.
Good. They all have an x squared. What else?
5
Yep.
at 2.
Beautiful. All right, now double check. Does this say 5 2x squared? Yup. Does this say 5 2x squared? Yup. Does this say 5 2x squared? Yeah. Now you can move on. Highlight the numerators, and that's what you're going to do. So what this guy says is 5x squared times x squared minus 9. That's the first part. This guy says 5 times 2, which is 10x times that. So there's a plus sign here. 10x times 3x minus 1. And this one just says minus 4. Daisy, help me out, babe. Can you distribute this for me? So 5 times x squared is, that's okay, babe. So good, 5x to the 4th. And what would this be, Daisy? Beautiful. Lachey, help me out with this one, babe. Can you distribute this for me? I'm sorry, babe. Negative 10. Yeah, don't forget the x. And then the minus 4. Makayo, what are the like terms, babe? Clean it up for me. Can you clean up the terms? See if they're... Sure. What do I get, honey? So the whole thing would be? Yep. Kanoa, what's the denominator? Good. So can I write 10x squared? Can I reduce this? Is there something I can take out of a 5, a 15, a 10, and a 4? No? So I'm done. You could try lightning bolt to see if it factors. That's actually a good idea. I probably should have done that. So if I do lightning bolt on top, let me see. What can I take out of a 5x4 and a 15x squared?
5x squared.
5x squared, and you're left with
X squared
minus 3. And here you could take out negative 2, and I'm left with, yeah. See how these are not the same? Then, yeah. Here's your doya. Just as a raise of hands, real quick, how many of you guys are going to do the retake? I'm sorry, for the free response. Okay. All right, here is your doyo. Help each other out if you need it. Find the comments. What's the first thing I should do? Check if they have a common denominator. Do they have a common denominator? All right, what does this guy have? X times x, very good. Isaiah, this is the part that we're missing. We need to write out what each group has so that's easier to see what we're missing. What does this guy have, Mina? That's its own number, guys. And this guy has just an x. All right, what's the first thing that you gave, Mina? I'm listening. Good. First term and third term gets 3x minus 1.
Morning, Cerritos High School. Please stand for the pledge for playoffs. Coach Watt will be getting his haircut at lunch in the quad today by Tim Wong. Come out and show your support. Go Dons!
Listen up, Dons. Come out and watch your girls basketball team as they take on Ontario High School here at home for the first round of CIF tomorrow night at 7 p.m. Good luck, Lady Dons.
Attention college-bound Dons. The LA County Association of Bilingual Superintendents is in community service. You might be eligible to apply. Come to Mr. Madison's room 405 for an application. They are due the first week in April. Don't delay. The early bird gets the worm.
Come out and watch your girls soccer team take on Santa Barbara in the first round of CIF playoffs. Tip-off is at 5 p.m. at the Feb.6 Sports Complex. Good luck, Lady Dons.
Don't forget to sign up for our Black History Month showcase on the 21st of February. Sign-ups end this Friday on the 8th. You can sign up with any BSU member or Miss Marbury in the counselor's office.
And now a special announcement from one of your commissioners of multicultural affairs.
To continue honoring our Black athletes this week, here's a quote from Muhammad Ali. "He who is not courageous enough to take a risk will accomplish nothing in life." Thank you.
Thank you, Kennedy. Club meetings.
Shakara and JNHS Dons, we will be having a general meeting today at lunch in room 301. Please come out to hear about our upcoming events like movie night.
And this has been your daily bulletin for Wednesday, February 6th, 2019. Have a wonderful Wednesday.
X squared times x? It's just x cubed.
Because that one already has x term.
It needs another x, no?
No, because it already has a 3x.
Like, for the second one, it doesn't have just an x. And I thought it
It does, babe. It has x times x right here.
Oh.
Got it?
If you're adding it, then it becomes 2x. But
There you go. If you're adding them, there you go. All right, here we go. I can explain now because it's over. This first term only needed a 3x minus 1. The second term just needed an x squared. The third one needed a 3x minus 1 and an x. Are we all in agreement on that? Yes or no? Yes or no? All right, so now we just got to distribute. 6 times 3x minus 1, boom, 18x minus 6. Negative x times x squared, boom, negative x cubed. Here I just did 3x plus 2 times 3x minus 1, and I got this. All of that multiplied times x, and you get this. I'm combining like terms now. Negative x cubed and 9x cubed, that's 8x cubed. 3x squared is by itself. A negative 2x and a positive 18x, that's 16x. And the negative 6 is by itself. Then, I want to see if I can factor anything out here. And nothing comes out. If I do lightning bolt, it's not going to be the same. So my final answer is going to be 8x cubed plus 3x squared plus 16x minus 6 over, FOIL this out or distribute it, you get 3x cubed minus x squared. Give me a summary, please, today I learned.